Hi everyone. So this is Ocelot load balancer, and in this video we are gonna discuss about the least connection load balancer. So least connection load balancer is a type of load balancer which tracks the request and send the request to uh, the least connected downstream service. So this is the least connection load balancer. And we in this lecture we will be deep diving into the low level code for Ocelot, and we'll see how we can debug and understand how the load balancer works. So for this, we have to clone this Ocelot repository, which is available in the GitHub, and then we have to just create the dummy projects, which I have already mentioned in my past video. I have committed that I have raised the PR for those demonstration of load balancer. So I'm just waiting to that PR to be merged to in the GitHub, so I can show you that uh, where I'm doing that. PR section, you can see my PR is already raised, where I have raised a PR for a load balancer sample, but still waiting for it. So, anyways, just I'm going to demonstrate what will be the load balancer, what will be the entry point of that load balancer, and how this Ocelot gateway works. So, talking about the first, I have to run up uh, my container or console. So my container console is up and running. I have shared the setup video in the previously I have shared this setup video. So you can check out over there. And in the Ocelot, I have created a load balancer demo for which I have raised this PR. It's under review. Anyone can just go and review that. So other people can also, the main contributors and the repository holders can just take a look early and just merge it. So what I'm trying to do is I have created a couple of instances, instance one and instance two. So moving on to the sample API gateway, it will be my program.cs. So this will be, I'm putting my debuggers at these couple of points, and I'm starting my application. So these will be the couple of points from which the complete application will have a middleware and a service agreements in the .NET Core application. So the first comes to register the services. So when we go, it's a Ocelot builder, and Ocelot builder will have all the services which we need, the Ocelot cache, Ocelot header files creator, post and port validators, route creators, the downstream, the fluent validators for dynamic creator if we have a dynamic route, the load balancers, QS for the HTTP poly, the service provider for console, load balancer creators, the type of load balancers, no load, round robin, least connection. So we will be using the least connection one. And the authorizers, authorizations, claims, downstream routes, HTTP client, and all the things, whatever required for the service registry, it's registered over here. So we'll just go out of it. And this is a service registry for console. This comes under the Ocelot provider.console, and this will be just registering the console factory, iConsole provider factory. This is provided by the console. So these interfaces are the overlap, but this can be provided. This is provided by basically it's a wrapper and it's provided by console. So just moving on, just setting a next point. So this is the entry point of a Ocelot pipeline. Here I am just entering into the pipeline. So this is a create configuration. It comes from the builder, and it just it does nothing. It's just the mapping around. It just maps into the object to C sharp from this Ocelot.json file. And this is the create Ocelot pipeline, build Ocelot pipeline. This is the main point where the building of the Ocelot pipeline starts. The downstream path, exception handle middleware, all the pipeline middlewares come up at this point. So this is not a WebSocket one. So we are not worrying about the WebSocket one. So it's WebSocket request. Yeah, let's see it over here. I don't know. So this will be no context. Yeah, this is not in the context, but this is not a WebSocket request. So ideally we'll not doing anything. It's just a pipeline request we are making, nothing else. So user responds with the Ocelot anything they want, so they can do it. Ideally we have to just look for the load balancer. Our load balancer middleware is over here. And before that, all the authorization, authentication, rate limiting, then it comes to the load balancer because definitely these are the first validations we need to be checked. And then we gonna assign the load balancer and we just do the HTTP request, then the middleware we call it. So at last we just make a downstream creation and we just make a redirection to that point. So this is a middleware. Uh, and this will be my point. And at this point, because there is no request, it was just pipeline was starting up. So this is uh, postman call. I was making the load test at that point. Forget about that. For this time, I'm making a get request call. And when I hit that endpoint, so here we go. So here is the load balancing middleware. So what it does first, it finds the downstream routes. So we're gonna have a couple of routes over here. We will be having the weather forecast host name. So there's a one host name, and for that host name, we have a couple of load balancer keys, the key pair 5022 and 5085, which is registered over here. So this comes up over here. Then the internal configuration, which comes from the Ocelot, the complete Ocelot pilot takes into the picture. Then here we start with the load balancer process. How the load balancer. So they have created one load balancer house. This is for the getting the load balancer and adding into a load balancer. This is having a couple of methods, but this is having a add one, a private one. So get a load balancer. So now moving on to the get load balancer house. So we are we gonna have the load balancer. Is there already a load balancer key? Yes. Then is it possible to just make a value out of it? So That's why it wasn't able to, because already not used. So it just tries through the factory. Let's go inside that. So it's a service provider factory. So we have a service provider, console provider we are using. So this is a console provider what we are using, and there is no error over there. Data we got, and created a load balancer response. So we have created our load balancer. Uh, Probably I think we should also be checking this. Yeah, so this is a point where it just checks the get asynchronous, and the lease assignment where it does cannot miss this process. Oh, oops, sorry. Load balancer, get async one. Okay, so uh, we are at this point. Console. Yeah. Uh, there is no, there is, they have created load balancer, adding a load balancer. It's just a key value pair, load balancer, and it has found the load balancer. So nothing less than that. Now it's a point where we gonna find the host and port, which is available for that. So this is a main point where the invocation gonna happen, and we gonna move to the create one. And this is a get async, the query result. Yes, we have found the console connected, and it has a service key, the console demo. Console demo is the service name by which these all services are registered. So service name is console demo, and because we have found the service, so service is there. Is there any node? Console have a nodes also. So yes, is there? There is a one node which have a service address, the service nodes, and then build a service. It builds a service. It has gets the version, post, port, everything, and it just creates the 502 to do the first one, the first service it has found, add it, and then return to the service. So after that, it will just add another one on the services, iterating on the Docker one. So it's just iterating on the console demos. So couple of there are a couple of services which are going to go down the stream, and it has a time assigned the instance one, and the point from which it has assigned really was that this connection. created a load balancer. This has created a load balancer, and then there's a load balancer. It is nothing just like let's add into the dictionary. It's a concurrent dictionary. Uh, this is a point where all the lease connection, the lease one gets invoked. So I forgot to just make a invocation over here. What it did is just I bypassed through this file. The service one invocation happens to the load balancer, and then what it does, it just invokes the next one. So we have to make sure to put a next debugger over here. So lease while well makes the host and port. So it comes to the because we have moved out of the services. So there are a couple of services available for the downstream, and it makes a synchronous lock. And then we update the service that okay, we are leasing this and we are assigning it. So because already the first one is engaged, so this is the second one because we are trying to find the second the vacant one. That's why. Uh, Now just we have to add it. There is already exists. There exists already existing definitely. Uh, I mean there is existing, but the previous one, but for this there is no connection exist. So just assigns like get the lease. So just get the lease for the which is the second one, the least one. So it tries to find over here is the point where this algorithm goes on. It will return the lease. So this lease 5085, which is the second one. That's why. So here it removes the lease. This the first one. The only second one with the first one will be the least of and least with the less least connections. So we have a host and port, the new one, and the connections. So and definitely we are making another connection. So we are making a lease that okay. We are now both of the connections are both of the ports are occupied. So from that and this is an algorithm where the main engine works on, and post is done, a downstream port is found, it schemes it, checks, and then invokes the next one. Like also it will hit another one, and here is a downstream and all the service fabric and service fabric request and all the merge, and then it will go to the move on to the next one. So definitely I have made a second request, that's why. So just while debugging, I have shifted a lot. So it's a instance one because first uh, first debugging was correct, second debugging failed, and third. So that's why now it will move to the instance two. So this is a least algorithm, a least connection algorithm, low level code of Ocelot gateway. So make sure just come to Ocelot gateway and do some contributions. Thank you everyone.